So the science of not just getting to Mars, but what we're going to do and what we're going to do when we get there and how valuable that is going to be. You heard it from 4 scientists who absolutely believe in the value of this and other exploration of our solar system. Pretty fascinating. One of the big reasons we're talking about sending humans to Mars here at the Humans to Mars Summit. George Washington University, Washington, D.C. I'm Matt Kaplan of the Planetary Society. We're into another break. As you heard, the group here is headed to lunch, and there are events underway during that period as well. We have a little bit more for you, the online audience. I'm going to be talking to Grant Anderson of Paragon. He was the moderator for the session you saw earlier today with those representatives from industry, as he is himself. We'll talk a little bit about that and maybe a little bit about keeping astronauts alive for 3 years as they go to Mars and come back and live there for a year. But first, we've got another video for you. This one is from the great NASA 360 video series, and it's called Science is the Goal. What's interesting about this, it was actually created from a presentation that was made at last year's, the 2015 Humans to Mars Summit here in Washington, D.C. So we're going to take a look at that, and then we'll be right back with Grant Anderson. Okay.
Nowadays, we're very used to these rich experiences with our mobile applications that we use on a daily basis. We're trying to bring in that modern aesthetic into the applications that we build here at Boeing. Boeing is not just an airplane manufacturer. They build awesome software as well. I design solutions for our customers that improve the efficiency at which they do their work.
For example, Flight Deck Fuel Advisor is a product that's in development and will shortly be into market. When I heard about it, I was intrigued. It's an application that provides the real-time fuel efficiency advisories to the flight deck. There's a fundamental performance relationship between weight and the fuel efficiency of the aircraft. Through proprietary algorithms, we can actually calculate what the accurate weight is. We can then provide more information to the flight crew in terms of how to operate the aircraft efficiently. Similar to the fuel efficiency gauge in the electric cars out there, you can see how efficient you're actually driving.
It's a complete paradigm shift, from the way that pilots and mechanics have done their work in the past. So we're now speeding up the process and the flow of information that a pilot needs to do his job.
Pilots like real-time access to data. They like being able to make informed decisions. The fact we can provide this fuel efficiency advice into a mobile application is game-changing.
So we're now leveraging these new disruptive technologies, such as tablets, mobile phones, wearable devices, to make the operation of the aircraft much simpler, much more elegant.
It's something that only a company like Boeing has the capability to do.
That's a side benefit. Hi.
Right. And
we're going to thank NASA for that 360 video. Based on that presentation, as we said, from last year's Humans to Mars Summit, as promised, we are now here with Grant Anderson of Paragon. I believe it's Paragon SDC, and I have to get back to the right place here so I can read my little bio of you. President and CEO of Paragon SDC, based in Tucson, Arizona, served as the company's chief operating officer prior to that, and before that at Lockheed Martin. Tell us about Paragon, first of all.
Okay, well, Paragon is a company that does life support in extreme environments, and we don't say just space because we don't do just space. We actually build contaminated water diving systems for the Navy, high altitude oxygen systems for skydivers. You may have heard that we broke the skydiving record 18 months ago, 135,000 feet with Alan Eustace. So where it's hard to keep things alive, where it takes technology to keep people or animals or plants alive, that's where Paragon works.
So with the panel that you moderated, you were up there with 4 representatives of companies that are nearly household words. They're certainly household words in the homes of aerospace geeks like me. Paragon's a much smaller company. What's the role of companies like Paragon in this effort to get men and women to Mars?
Well, it really comes down to probably directed innovation. The small companies, of course, we have access to small business innovative research type grants and stuff of that nature, but we concentrate on things that are maybe too small for a large company like that to think about, but big enough for us to think about. Paragon has developed probably the best water reclamation system that's available for space with 98% efficiency, oxygen generation systems out of CO2 and stuff. And those are payoffs that I think for a larger company, they don't quite see the return on investment given all the other big R&D they can do. So we bring that sort of directed R&D environment to these companies. Now, these companies do pay us to go do this stuff sometimes, but we're sort of a ancillary to the larger R&D budget that they have.
And most of our audience knows there are hundreds, probably thousands of sub and sub-subcontractors like Paragon.
Yeah, and I mean, if you've ever seen the maps of how many different companies in different states are on Orion or something, it's all over. I mean, it's almost every single state in the union. It takes a village. Can I say that here? It takes a lot of people concentrating on what they do best to come up with the best answer to what the needs are of a company or the marketplace or the country.
All right, let's get to the meat of what I'm hoping will be really what I want to get to in this very short conversation with you that we have during this break at the H2M Summit. And you've already sort of segued into it. You've been working on life support systems yourself, designing them, building them for over 30 years. Mm-hmm. Are we going to be able to keep astronauts not just alive, but comfortable on a 3-year journey tens of millions of miles away?
Yeah. Well, define comfort. It's not going to be a pleasure cruise. There's no question about that. But yes, I'm very confident that the technologies exist to keep people alive that long. Really what it comes down to is the implementation of that technology. And can you get the mass and the skills for the maintenance of that on board so that you can keep it going for that length of time? It's really an implementation problem. And test. We did the Inspiration Mars study. We headed that up with Dennis Tito, and in that I think showed very conclusively that the technologies were there to do this. We had the state-of-the-art technologies. There was very little development work to be done, if at all, in the life support arena. Where it really was is implementation. The space station is a wonderful vehicle, but it does have a lot of maintenance. If you look at papers about the maintenance load and the amount of time that astronauts use to maintain it, and the ORU sizes. I mean, the ORUs on space station are 100-pound orbital replacement units. I should probably define that. And you can't do that to Mars. So the ORU has to be O-rings. It has to be, motor windings. It's got to be things that you can change out that are small that you can carry 2 or 3 with you in order to fix the system. And that sure sounds easy, but have you ever tried to maintain your 2016 Lexus? There's so much electronics and everything else in there. It takes a real gaggle of specialists to keep even a car on the road. But here we're talking about 2 or 4 or 6 astronauts having to do everything by themselves. So that designing for simplicity, and it's a lot harder to design something simple than hard, than complex, is really key. And getting those designs done, getting them tested on the ground, a little bit like one of the questions we had, that I had, is getting the number of test cycles in and full duration mission test cycles in so you're confident that you can keep it going is the hard part. It's not actually the technology itself.
So you've surprised me with this by saying the technology exists. What really needs to happen is we need to get better at the implementation. I thought that really turns it into kind of the same sort of just a question of scale that we've been hearing about here with like solar electric propulsion and habitats, the habitation module and so on. Is it really just scaling and then making sure it works in the real environment?
Well, it's never really just anything in engineering. One of the things that the picture that was shown during my panel of a kind of a notional solar electric system, that was a megawatt grade system, which is not necessarily what you need to go to Mars. We're talking, I was talking to one of the panelists a little later, I won't mention which one, said, really we need about 150 kilowatts. Well, I was the chief design engineer for the solar arrays for space station when I worked at Lockheed.
You built really big ones.
Yeah, we built, and the end-of-life power of those 8 arrays that are up on space station is 186 kilowatts. So we're talking about less arrays than are on station now, actually feeding our electric propulsion system going to Mars. But again, that's not my business anymore. You know, I'm in the environmental control business. I should say that the technology exists. Could there be better technologies? You've got to have the on-ramp for them. You know, some of the CO2 absorption technologies and desorption technologies. There's new things coming down the street that are better, both in weight and operability, and that is part of getting again, that maintenance load down. That's what it's really going to be concentrating on. So I'm not saying that the technologies like where we have flying on station are going to be exact ones that go to Mars. There's going to be some evolution and development and inserting of new technologies, but it's going to be very carefully done and carefully tested.
You had told me previously, hey, are we still on? Oh, yes, we are. They just took us out here in the hall, so I got shaken up because we've been hearing our voice reverberate here at GWU. You had told me previously about this achievement of 98% efficiency in reclaiming water in this system that Paragon has developed. Sounds incredibly impressive. Is that going to be adequate? I mean, obviously, even that 2% of inefficiency over 3 years, they're going to have to bring a fair amount of this wet stuff with them.
Yeah, well, actually, with water, it's an interesting thing because it's not just the water you bring on board that you're drinking and you're urinating and then transferring back in and you're drinking yesterday's coffee, as they say. But you are also, of course, consuming food, and your body is metabolically producing, changing food into energy for you. And in that chemical reaction, you take the hydrocarbons and stuff that are in the food, and or the caloric intake of food, and you convert that to CO2 and water. So you actually have more water on board than just the water in the tanks. So when you get to 98%, you're almost, you might be having to dump water overboard. You know, you've got extra water in the food. Now, where does the food come from? On a short-term mission, it's going to be brought with you. You're going to be eating a lot of power bars and stuff like that, but it's going to be packaged and brought with you. Once you get on the ground in Mars, and as long as you have a good power source, you're going to start growing the food.
Potatoes.
And potatoes, yeah, and probably not in the night soil as described by Watney, right? Yeah, but yeah, and so. Yes, we think 98% is very adequate and very good, and especially since our technology is like one moving part. And so it has everything, simplicity and the ability to turn. But one of the things we have to watch out for as technologists is aiming for those extra 5%, you know, of performance. Say you have a 92% capable oxygen regeneration system, so pulling oxygen out of the CO2 or out of the excess water. Okay, so now you have a new technology comes along that says 97%. Well, what you've got to do that is look at it over a mission. Well, what is that extra 5% going to do? It's going to save you maybe 200 kilograms of oxygen for, 4 people for, about 1,000 days or whatever.
And new systems integration work.
Well, but if it takes 100 moving parts to get 97% and it only takes 5 moving parts to do 92%, by the time you draw the box around the real trade, which is all the logistics of maintenance and spare parts and everything, you actually will have less weight with a 92% capable system than a 97% capable system. So you got to watch out and make sure you're doing the trades right.
Grant, I wish we had a little bit more time to talk, but we are moving on now to an interview with the NASA administrator, Charles Bolden, that was recorded a while back.
I'm glad I could tee it up for him.
You don't want to stand in Charlie's way, I'm sure. Thank you so much for doing this.
Oh, thank you very much. It's been my pleasure.
Grant Anderson, he is the president and CEO of Paragon STC, moderated a panel of industry experts, industry representatives, vice presidents in that case, from the 4 major partners that are leading the industry side of the effort to get humans to Mars, with the help and cooperation and collaboration of companies like Paragon and hundreds of others. All right, we are going to go now to that long interview that was conducted with Charles Bolden, the NASA administrator, administrator, outgoing NASA administrator, although he'll be in there for a while longer through this administration. When we come back, and that'll probably be at about 1:35, we'll have more for you live, you, the online audience, for the Humans to Mars Summit, to take us up to about 2 o'clock when the program will start again on the stage right behind me. So I hope you'll stick with us. I'm Matt Kaplan from the Planetary Society, here reporting for Explore Mars from the Humans to Mars Summit. Let's go ahead and we'll roll that video with Administrator Bolden now. We'll see you soon.